267,000 people in one Japanese prefecture are under evacuation orders right now, 3 days after an earthquake killed 34 of their neighbors. 1,400 emergency responders are already on the ground, and 4 days out in the open Pacific, a storm sitting at the very top of the intensity scale is turning west toward Japanese territory. Whether those two disasters meet is unresolved, and the forecast has already swung once, hard. By the end of this, you will know what a typhoon does to a place that is already broken, and the three signals that decide this. Super Typhoon Dolphin is now the strongest tropical cyclone on Earth in 2026, and it reached that status in a stretch of ocean where a storm this powerful has never been recorded before. The system, designated Typhoon number 13 of the Western Pacific season and 12W by the Joint Typhoon Warning Center, hit Category 5 equivalent intensity late Wednesday into Thursday over open water near Wake Island. Operational analysis put its peak at roughly 165 miles per hour sustained, with a central pressure near 910 millibars. A retroactive upgrade to 175 miles per hour has been circulating among storm analysts. That figure is not confirmed in official best track data yet, and it should be treated as a claim rather than a measurement. The Japan Meteorological Agency, which uses a 10-minute wind average rather than the 1-minute average American agencies use, classified Dolphin at the top of its own scale. The category the agency labels violent. With a central pressure of 910 hectopascals, sustained winds of 55 meters per second, and maximum instantaneous gusts of 75 meters per second. The Joint Typhoon Warning Center's 1-minute analysis placed sustained winds near 270 kilometers per hour. Across the day, compiled operational estimates spanned 150 to 165 miles per hour sustained, gusts of 185 to 200, and central pressure anywhere from 895 to 920 hectopascals as the storm's core reorganized. Here is what makes it a record. Dolphin reached Category 5 intensity at longitude 166.5 degrees east, the farthest east any tropical cyclone has ever reached that intensity in the recorded history of the Northwest Pacific Basin. The previous mark belonged to Super Typhoon Faye in 1968, at 162.7 degrees east. Dolphin is the strongest typhoon on record to develop this close to the international dateline. It is also the second Category 5 super typhoon of a single July, something that has happened only 3 times ever, and not since 2014. And it is the 5th Category 5 tropical cyclone on the planet this year, all 5 of them in the Pacific. None of that would be the lead story if the storm were not moving toward a country that is currently in the middle of a different disaster. Japan is running 2 emergencies in the same week, and only one of them has arrived. On Tuesday afternoon at 27 minutes past 4 local time, a magnitude 7.1 earthquake struck Kumamoto Prefecture on the island of Kyushu at a depth of about 10 kilometers. That is the Japan Meteorological Agency's magnitude. The United States Geological Survey revised its own moment magnitude to 6.8. The difference is a matter of measurement scale, not disagreement about severity. What both agencies agree on is what the shaking did. The quake produced Shindo 7 at Uki City and Hikawa Town. Shindo is Japan's seismic intensity scale, and it measures what the ground actually did to buildings and people at a specific location, rather than how much energy the fault released. The scale ends at 7. There is no higher value to assign. 2 municipalities in Kumamoto Prefecture experienced the maximum shaking intensity the Japanese system is capable of expressing. As of the Fire and Disaster Management Agency's reporting yesterday, 34 people are confirmed dead. 11 in Yatsushiro City, 7 in Kamiyamakusa City, 4 in Hikawa Town, 2 in Uki City, 1 in Kosa Town. 9 additional deaths remain under investigation. 123 people are injured, 5 of them seriously. 89 required medical treatment. Rescue teams have pulled 98 people to safety and transported 620 others out of the affected area. A tsunami advisory went out for the Ariake and Yatsushiro seas 2 minutes after the rupture, warning of waves up to about a meter, and it was lifted roughly an hour and 40 minutes later. Officials confirmed one house destroyed outright and another partially collapsed, with several buildings taking flooding or other damage. Emergency crews have been working isolated failures across the prefecture. A collapsed factory chimney in Yatsushiro City. The partial collapse of the second floor of a commercial building in Kamiyamakusa City. Critical infrastructure came through without reported damage, which is the single best piece of news in the entire situation report. Aftershocks are continuing, several of them reaching Shindo 5 lower, strong enough to knock objects off shelves and to finish the job on a wall that survived the main event with a crack in it. Disaster response headquarters remain active in Kumamoto and in neighboring Nagasaki Prefecture. That is the state of southwestern Japan today, and the number that matters most for what comes next is not the death toll. The displacement figure is the one that changes this story. Kumamoto Prefecture has issued evacuation orders affecting 127,647 households, approximately 267,285 people. On top of that, emergency safety measures cover another 46,610 households, or 92,743 people. More than 250,000 residents of a single Japanese prefecture are currently under evacuation orders. Thousands of them are physically inside shelters right now, gymnasiums, community halls, public buildings, where crews have been running additional power sources in to keep air conditioning going through a Kyushu summer that has already produced a record streak of 40 degrees Celsius days nationally this month. These are not people who are back in their houses. These are people whose houses are either damaged, unsafe, or inside a zone the prefecture has not cleared for return. The response side is committed too. 9 prefectures have deployed emergency firefighting teams into Kumamoto, 347 ground personnel and 4 helicopters, part of a combined local and national force totaling roughly 1,400 people. That is a significant fraction of Japan's mobile disaster response capacity, concentrated in one prefecture, 3 days into an operation that is still active. Now hold that picture. 250,000 people displaced, structures damaged and unassessed, 1,400 responders already deployed, aftershocks ongoing, and put a top-of-scale typhoon into the forecast. That is the story. Not the earthquake by itself and not the storm by itself, but the calendar overlap between them. Dolphin got this strong faster than almost anything the forecast agencies have a benchmark for. The formal threshold for what meteorologists call rapid intensification is an increase of 35 miles per hour in sustained winds over a 24-hour period. That is the line a storm has to cross to be flagged as intensifying rapidly. Dolphin went from Category 1 to Category 5, equivalent strength in roughly 24 to 36 hours. It did not cross the rapid intensification threshold. It cleared it by multiples. Satellite imagery through that period showed the signature of a storm doing everything right, meteorologically speaking. A sharp, warm, well-defined eye, ringed by intense convection, unusually symmetrical, with a compact core. Compactness matters here. A small, tight core has less mass to accelerate, which means a favorable environment can spin it up faster than it could spin up a sprawling system. It also means the storm is more volatile, quicker to strengthen and quicker to fall apart when conditions turn. Position yesterday put Dolphin near 16.4 degrees north, 165.7 degrees east, roughly 320 to 335 kilometers south-southwest of Wake Island, moving west-northwest at about 17 to 20 kilometers per hour. It passed south of Wake at or near peak intensity. No populated landmass was under direct threat at the time. The forecast intensity numbers are where this gets less certain, and it is worth being precise about what is measured and what is projected. The Joint Typhoon Warning Center at one point forecast Dolphin to reach 190 miles per hour later this week, a figure that would put it among the strongest tropical cyclones ever observed anywhere on Earth. Claims circulating online have suggested a peak near 185 miles per hour with gusts to 220. Earlier official guidance projected something closer to 170. Every one of those figures is a forecast. None of them is an observation, and the reason they keep moving has a name. Dolphin's peak wind number has been unstable all week, and that is not a measurement problem. It is the storm's own structure cycling. An intense tropical cyclone has an inner eye wall, a ring of towering thunderstorms wrapped around the calm center where the strongest winds live. When a storm gets very powerful, a second ring of convection can organize farther out. That outer ring starts competing for the same inflowing air, and it wins because it is drawing on a wider circumference. The inner eye wall gets starved and collapses. The outer ring contracts inward and becomes the new eye wall. The storm reorganizes around a larger eye. This is called an eye wall replacement cycle, and it does two things at once that seem contradictory. Peak winds drop, sometimes substantially, 10 or 20 miles per hour or more, because the tightest, fastest ring has just been dismantled. But the wind field spreads outward. The area experiencing damaging winds gets bigger even as the maximum number gets smaller. A storm that has just completed a replacement cycle is often less intense and more dangerous at the same time, because destruction scales with how much ground you cover, not just with the peak gust at a single point. And when the cycle finishes, the storm can re-intensify from its new configuration. Dolphin has been through this repeatedly. Analysts tracking the system report at least one completed replacement earlier in the week. and by yesterday, the completion of a third, with a larger new eye clearing out in the central cloud shield, roughly doubling in size over 24 hours. Mesoscale model guidance shows another cycle possible within the next 12 to 24 hours, which would impose short-term weakening again. That is why any single headline wind speed for this storm is close to meaningless as a guide to what it will be capable of when it approaches land. What matters is the environment it is moving through, because a storm that keeps rebuilding itself will keep reaching for whatever ceiling the ocean gives it. And it gets more complicated from here, because the question of where it goes has already been answered wrong once. The track guidance for dolphins swung dramatically inside 48 hours, and that swing is itself one of the more important facts in this story. 2 days ago, the consensus carried dolphin toward a landfall in southern Japan. The latest guidance shifted the storm substantially westward, onto a path much closer to the one a previous typhoon took before making landfall near Hong Kong late last month. That is one of the largest track revisions this system has seen since it became a super typhoon. Under that solution, dolphin continues west-northwest along the southern edge of the subtropical ridge for about 2 more days, then bends westward at 20 to 25 kilometers per hour, approaching the waters north of Taiwan around the 5th of August and eventually aiming toward the Fujian and Zhejiang coast of China, by which point most guidance has it down to Category 1 or 2 equivalent intensity in the East China Sea. Other guidance keeps western Japan and Kyushu in play. Forecast discussion has flagged a possible strong typhoon impact near Okinawa the following week, with models genuinely split about whether the storm tracks closer to Taiwan or closer to Japan around 6 days out. What is not in dispute is the near-term Japanese piece. The Japan Meteorological Agency's forecast carries dolphin toward the seas near Minamitoroshima tomorrow and Sunday, then bending toward the Ogasawara Islands on Monday and Tuesday. Those islands are Japanese territory. The current expectation is a near-direct approach while the storm is still at what the agency calls very strong intensity, with a storm force wind field and swell running ahead of the center. Residents and authorities there have been told to prepare for destructive winds, torrential rain, storm surge, and extremely high waves. It is worth understanding why the track forecast wobbles this much when the intensity forecast is comparatively stable. Intensity is governed mostly by conditions the storm is sitting in right now: water temperature, wind shear, the state of its own eye wall, and those are measured directly. Track is governed by the steering flow days ahead of the storm in air that has not been sampled yet, and small errors in how a model handles a ridge of high-pressure compound with every hour of forecast lead. That is why a 5-day track is a cone and not a line, and it is why a storm can be forecast with reasonable confidence to be extremely powerful, while nobody can tell you within several hundred kilometers where that power ends up. So the honest summary is this: the Ogasawara approach is high confidence, and it is coming in 3 to 4 days. Everything past that is a real model split, and the westward solution, the one that has gained ground, sends dolphins' remaining energy into the East China Sea corridor rather than into Kyushu. That should be reassuring. It is not entirely, and the reason has to do with what happens when 2 disasters land in the same place. Disaster researchers have a consistent finding about consecutive hazards striking the same location. The combined impact exceeds the sum of the individual events. It is worth walking through why, because the mechanism is concrete and it applies directly to Kyushu right now. Start with the buildings. A structure that survives a magnitude 7 earthquake has not necessarily survived it intact. Roof tiles shift and lift, wall connections loosen, foundations crack. A house that is standing and looks fine from the street can have lost a large fraction of its capacity to resist lateral load, and wind is a lateral load. Damaged roofing that held through 3 calm days comes off in a 60-mile-per-hour gust. Buildings that would shrug off a typhoon in normal condition fail in damaged condition. And in Kumamoto Prefecture, thousands of structures have taken earthquake damage that has not been repaired, and in many cases has not yet even been inspected. Then the ground itself. Seismic shaking reduces the cohesion of soil on slopes. Post-earthquake landslide susceptibility stays elevated for months, sometimes years, after a major event. Hillsides that were stable before fail at rainfall totals they use to absorb without trouble. Kumamoto Prefecture is mountainous, and heavy summer rain already drives landslides there in ordinary years. A typhoon's rainfall arriving onto slopes loosened 3 days ago by a magnitude 7.1 is a materially different hazard than the same rain falling on undisturbed ground. Then, the shelters. Evacuation sites are chosen for the hazard at hand. A school gymnasium on flat, open ground is an excellent earthquake shelter. A large, reinforced single-story space away from things that can fall on you. That same building may sit in a floodplain or at the base of a slope or in a location that is entirely wrong for wind and water. Populations sheltered for one hazard sometimes have to be moved for the next one, and moving a shelter population is slow, difficult, and exactly the kind of operation that gets harder when the weather is already deteriorating. And then the responders. 1,400 emergency personnel are deployed in Kumamoto right now, 3 days into an active operation, drawn from 9 prefectures. They are tired. Their equipment is committed. The reserve that would normally be available for a new event in Western Japan is currently working an existing one. Emergency management is a finite resource, and Japan's is the best in the world precisely because it plans for that arithmetic. But the arithmetic still applies. That is the compound hazard problem. It is not about whether Dolphin's center passes over Kumamoto. Even a glancing outer band, even a track that stays well west, delivers rain and wind to a prefecture that currently has the least margin for absorbing it of anywhere in the country. None of this is happening in a random ocean. The Pacific is in a specific state right now, and that state is why a storm reached the top of the scale in a place where storms do not normally reach the top of the scale. The Oceanic Niño Index, the standard measure of El Niño and La Niña, stands at plus 0.98 degrees Celsius for the April through June period. That is an established El Niño, and it is still warming. The progression to get there is unusually fast. 6 overlapping seasons ago, the index sat at minus 0.54, then minus 0.37, then minus 0.14, then plus 0.13, plus 0.51, and now plus 0.98. That is a swing of 1.52 degrees Celsius from La Niña to established El Niño in roughly a year. Sea surface temperature in the Central Pacific monitoring region climbed from about 26 degrees Celsius to nearly 29 over the same stretch. Here is why that matters for dolphins specifically. A tropical cyclone is a heat engine. It pulls energy out of warm surface water, converts it into rising motion and heat release in the eye wall, and vents it at altitude. But surface temperature alone does not determine how strong a storm can get. What matters is how far down the warm layer runs, the ocean heat content. A storm churning across a thin warm layer stirs cooler water up from below and throttles its own fuel supply. A storm over a thick warm layer never hits that break. During El Niño, the Western Pacific warm pool and the typhoon genesis region shift eastward. Category 5 typhoons normally mature far to the west, over the thickest water near the Philippine Sea. Dolphin reached the top of the scale nearly at the international date line, which means the water out there, far east of the usual factory floor, was warm enough and thick enough to build a top-of-scale storm. The basin record is not a curiosity. It is a direct readout of where the fuel is this year. Underneath, the El Niño signal is a slower one. Global ocean heat content in the upper 2,000 meters set a record for the 9th consecutive year in 2025. June of this year was reported as the warmest global ocean on record for the month in independent datasets. The theoretical ceiling on how strong a storm can become in a given environment rises as the ocean warms. A warmer ocean does not necessarily produce more storms. It raises the ceiling on the ones that do form, and it shortens the time they need to get there. Dolphin is not the only storm that demonstrated this in the past week. It is the second one. Hurricane Genevieve reached Category 5 intensity in the eastern Pacific on Monday, the first Category 5 hurricane anywhere on Earth this year, and the first in the eastern Pacific since Hurricane Christy in October of 2024. Genevieve peaked at approximately 160 miles per hour with a central pressure near 929 millibars. Its intensification profile was the same shape as Dolphin's. The storm roughly doubled its wind speed, from 80 miles per hour to 160 in about 30 hours. Genevieve has weakened since. As of yesterday, it was a Category 2 with sustained winds near 100 miles per hour, roughly 735 miles west-southwest of the southern tip of Baja, California, moving away from land. It will not make landfall. Its practical impact is large south swells driving dangerous surf and life-threatening rip currents along the beaches of southern California, Baja, and southwestern Mexico through the weekend, which is a real hazard and a reminder that a storm does not have to come ashore to kill people. 2 Category 5 tropical cyclones in 2 basins of the same ocean within 3 days of each other, both of them blowing past the rapid intensification benchmark by multiples, both of them fed by the same warm water, and the contrast on the other side of the continent is just as telling. As of the latest outlook cycle, the Atlantic had no active tropical systems at all. It has produced no hurricanes this season, while the Pacific has produced all 5 of the planet's Category 5 storms for the year. That is textbook El Niño behavior. enhanced wind shear across the Atlantic tearing developing systems apart, while the Pacific runs hot. It is one atmospheric pattern producing opposite outcomes in two oceans. It is also worth stating plainly what is not driving any of this. Available space weather records show no geomagnetic storms and no high-speed solar wind streams through this period, with only low-level flare activity. The strongest recent event, a moderate M-class flare on Sunday. Solar activity is not intensifying typhoons, and it is not triggering earthquakes. The energy involved in a single Category 5 tropical cyclone dwarfs anything the current solar cycle has delivered to the upper atmosphere this month. The ocean built this storm. 3 things will determine how this resolves, and all 3 are observable. The first is the subtropical ridge. Dolphin's entire track depends on the strength and westward extent of the high-pressure system it is riding around. If the ridge holds firm and pushes west, the storm gets driven toward Taiwan, and the East China Sea and Japan's main islands are spared. If the ridge weakens, Dolphin turns north earlier, and western Japan comes back into range. Global models disagree about how that ridge evolves, which is the entire reason the 5 to 7 day forecast is a spread rather than a line. Watch for the guidance to converge, or not, over the next 2 days. The second is the next eye-wall replacement cycle. If another cycle begins in the next 12 to 24 hours, Dolphin weakens temporarily, and its wind field widens. Whether it completes that cycle and re-intensifies before reaching the Ogasawara Islands determines what those islands actually experience on Monday and Tuesday, and it determines how much intensity the storm carries west after that. The third is what Japan does with the window it has right now. The Ogasawara approach is close to settled. Everything beyond it is not. And the practical response to an unsettled forecast is not to wait for certainty. It is to use the days of lead time that exist. For Kumamoto Prefecture, that means assessing whether shelter sites chosen for an earthquake are appropriate for wind and water, inspecting damaged structures before rain arrives rather than after, and identifying which slopes above populated areas were destabilized by Tuesday's shaking. The forecast may well move again. It has already moved once, substantially, and the westward shift is genuinely good news for Kyushu. But 250,000 people are under evacuation orders in a prefecture with damaged buildings, loosened hillsides, and a response force that has been working for 3 days straight. And the strongest storm on the planet is 4 days out with a track that is not yet locked in. We will know a great deal more by Monday. Until then, the useful posture is preparation rather than prediction. And the specific thing worth watching is whether that ridge holds.